Let's discuss when a rational function is zero or undefined and positive or negative. Let me start with some basic rules for fractions because a rational function is just a fraction. If you take 0 and divide it by a number that's not 0, you get 0. If you take a number that's not 0 and divide it by 0, that is not defined, or it's undefined if you want, not defined. A positive divided by a positive is a positive. A negative divided by a positive is negative. Same thing with a positive divided by a negative, and a negative divided by a negative is positive. So the rules for division are much like the rules for multiplication with positives and negatives. Let's do a couple more simple examples. We'll be seeing things like this quite frequently where you have multiple signs. So positive times positive would be negative, and on bottom positive times negative will be positive, and negative divided by positive is negative. In general, all you have to look at is your negatives. If there's an odd number of negatives, then the answer is negative in multiplication or division. Or if there's an even number of negatives, the answer is positive in multiplication or division. So here's a rational function, a fraction. The easiest way to do this is to rewrite it as y equals and factor everything out so it's multiplication. The bottom is important to write as x plus 2 squared. And now let's figure out where it's 0, not defined, positive, or negative. For a fraction to be 0, the numerator has to be 0. While the x values that make the numerator 0 are x equals 1 and 2. So if x equals 1 or 2, then the y value is 0, because y would be 0 on top divided by a number. When is it undefined? Well, it's undefined when the denominator is 0. So negative 2 for x would make the denominator 0. So if x is negative 2, y is a number divided by 0, which is not defined or undefined. Okay, and now let's look at where it's positive and negative. That's a little bit harder. So I've marked the places on the x number line here. These are x values, where the function is not defined 0 or 0. So that means all these other regions here, all these other x regions, have to be positive or negative. Okay? So we need to determine which intervals have what sign. I want to start with the first region here, left of negative 2. Okay? If x is less than negative 2, let's say it's a number that's over here might be negative 4. Let's take this negative 4 and plug it in for all the x's into this expression. If we do that, we get y equals negative 4 minus 1, that's negative. Negative 4 minus 2 is negative. Negative 4 plus 2 is negative, but then when you square it, it's positive. So in this region, a negative times a negative divided by a positive is, of course, a positive. So this region is positive. Now we can use the exponents on all of the factors that these negatives and positive numbers came from. So for example, negative 2 came from this x plus 2 in the denominator. The exponent here is even, so let's put an e up here for even. The 1 came from x minus 1 to the first. 1 is odd, so I'll put an O here for odd. 2 came from x minus 2 to the first, so that's also odd. And if you'll remember from polynomials, when you cross an even exponent here, the sign stays the same. So plus stays a plus, so this region's positive as well. And when you cross an odd exponent, the sign changes. So this region's negative. And when you change a negative again, this region would be positive. So this function, this rational function we have here, we first put in factored form, found where it's 0 and not defined, and we split up this number line, this x number line, which by the way is the same thing as the x-axis. And then we determine which intervals this function was positive or negative by looking back at this factored form here. So we plugged in a number negative 4 for all the x values, and we saw that y was positive in this region. And then we got the exponents marked, even, odd, odd. And when you cross an even, the sign stays the same, and when you cross an odd, it changes. So in the first region, the rational function is positive. Second region is positive. Third region, it's negative. Fourth region, it's positive.